Hello everyone. In this video, we will discuss about how to export floor framing plan from Autocad to Etabs. The first step is to prepare the framing plan based on the given architectural plan. Let me open the architectural plan in Autocad. This is the architectural drawing given by the client. So we need to prepare the column and beam location such a way that it will not affect the aesthetic point of the architectural drawing. The structural engineer should study the architectural drawing thoroughly and then plan for the column and beam location without collapsing the aesthetic of the architectural plan. In structural consultancy firm, typically structural engineer design the structure using the analysis software like Etabs and StatPro or some other software as well, and then give the structural input to the structural draftsman, and structural draftsman prepare the structural drawing, and the structural drawing is given to the site for the execution. This is how the system is working in the structural consultancy firms. I already have planned for the column location such a way that it will not affect the aesthetic of the architectural plan, which means I did not provide column anywhere inside the living room or bedroom or some other way which will affect the beauty of the archi plan. For example, this is the parking area. I have given column external and inside of the building, and this is the first floor plan. I kept a column at here, here and here, which is in line with the partition wall, and I kept a column at here, here and here, and then here, and then this is the lift area. I kept column along the wall direction, and this is staircase. All four corner I have given a column, and this is a column to resist the balcony slab and also for the above floor slab. So this is how I provided the column, and then this is the beam location I superimposed with the archi plan. This is the plinth beam diagram which we need to connect column to column on both major and minor axis. So I have given the beam all the two directional tie to the column, and this is the first floor. I have a given beam at here, here and then here. This is the bathroom. I have given a sunken slab at here and here. Here, this is the bedroom. I have given beam here which will not affect at this floor plan. Since it is given in the first floor level, this beam will be visible only in the parking area. This is the first floor beam. So this is the first floor bedroom. You will be able to see this beam depth after the slab detection. You will be able to see only standing in the ground level. Also have given beam at here to tie the minor axis of the column to improve the structural stability, and then I have given also beam at here to support the external wall. Here I have given beam to tie these three columns also to support the external wall, and then I have given beam at here and then beam at here. Here I have given beam to sunk this slab in the toilet area, and then I have given beam like this to tie these columns, and then here I have provided 3 feet cantilever slab. Here I have provided inverted beam so that if I provide a beam at here, it will be look in this first floor area. After the slab detection, you will be able to see the beam from the first floor. So what I have done, I have inverted the beam. After the slab, I have inverted the beam in line with the second floor wall. So you will not be able to see standing in the first floor, and this is the terrace floor plan. So this is how I have prepared the framing plan. So this is a plinth beam, and then ground floor, first floor roof, second floor roof, and then this is the headroom. So comparing all these four framing plan, this seems difficult to model in the Etabs. So it is advisable to take the critical floor plan to export to the Etabs. Let me copy this. Then here we have to make the center line of the beams. Comparing the center line of these each beams. The structural engineer should know minimum knowledge of the Autocad to access the Autocad file. Here it is a balcony and it is only one line, so I prepare the line at here. So all the horizontal beam center line I have marked, and then similarly let me mark for the vertical direction beams. Trim the additional lines. So this line is still here. This line from this to this, and this line should be trimmed at here. This beam is from here to here. Similarly here. The horizontal line is made as per the beam location. Now we correct for the vertical beams. This beam is still here, so I trim this line at here, and similarly this beam is still here. I am trimming this to this. This is the extension of the slab. We cannot create a central line of it since it is a single line. So mark this external line. I am marking this external slab line same as a center line. So I am using the same layer like this and like this, and connecting this with this. So this is the central line of the beam and this is a slab extension line. So we have prepared the center line based on the beam location. We need to trim this to till here. Check one more time. It's all done now. And then I have drawn the center line using the layer column. When you are clicking, the respective layer will be shown here. So I picked the column layer for the center line. For the reference, I am changing it to beam line. And the column center line I did not draw here, since the column center line and the beam center line is not the same as per this floor plan. Since the column center point is here and the beam intersecting point is here, so it is not exactly resting on the CG. Either what we can do, we can make a rectangle like this and shift it to center point while exporting, or you can directly add a column in the Etabs itself by referring this drawing. Better we draw the beam center line only and add the column by referring the drawing in the Autocad and draw it in the Etab. That would be easiest for you. So I am not drawing the center line of the column here. I am copying this beam center line using lay ISO. I am copying and keeping it side. Now we can change this layer to the beam layer using match property. Save as this file to DXF file. Version I go for 2010 DXF and let it be the same name and save. Delete all other drawing. So in this DXF file, this is the only drawing remains here. The rest all deleted. Again, using the purge, I delete the unwanted block objects. Then save. Now close it. Click on no. It is asking for saving it to the DWG format, which is AutoCAD format. Now we will import the DXF file to the Etabs. Open the Etab. Click on new model. This setting I already explained in the previous tutorial video. You can check it out. All these three options, how to use. So if you want to know, you can check the previous video. Use setting from a model, which means I already have completed the model and analysis for one project, and I am extracting the design units and preference like load combination and code, everything from the model which I already have done. So click this setting, check this one, and then click OK, and then click Etab. This is the file which I am talking about. This is already completed. I am taking the basic input from this file, and I am not modeling with the grid system. This we cannot keep 0 0. Let it be 4 and 8. And here I am changing to 2-story, and the story height remains 3 meter and 3 meter. I don't change it. Click on OK. After clicking OK, now we are able to delete this grid by selecting add or modify grid and then modify show grid system. Here delete these grids and then click OK. Now go to file and click on import. Click on DXF or DWG file of architectural plan and select the file you saved. This is a DXF file I saved in this location, and open. The drawing units are in inches, so I am selecting the drawing units and the drawing to be reflected in the story 2. and I am unchecking the add center lines, which means for every beam there will be a center line add by the default by checking this option. I am unchecking this and click OK. Now check in the 3D view. This is the architectural layer. You cannot make any changes in this. This is not the editable one. So what you can do, go to display. There are 4 options, which is model, display, tables and reports. Click on display and click on architectural layers, and this is a beam layer which is imported from the DXF file. Right click here and click on add beam object, which means you are adding the beam on the architectural layer like this, and then hide this architectural layer. Now the beam has been added in the architectural layer like this. Now what we have to do, we have to split these lines for each intersection. Since in the Autocad I have drawn this as a straight line, whereas in Etabs program we need to intersect each column to column intersection of the beams and beam to beam intersection to be splitted. So I am selecting everything and go to this option, divide frames. This is a quick setting. You can either go this way also, edit and then frames, divide frames, and click this break at intersection with the selected frames and joints. Now each intersection has been splitted. Now we will add the column. I am keeping these side by side, Autocad and Etabs. The column locations. I click column, I click the property, I go for 230 by 600. Since many of the column is in the horizontal location, here, 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 here and all, and very few columns are in the vertical location, either we can change each column rotation respectively, like this horizontal column. If you want to keep vertical column, you can keep provide 90° here and provide a vertical column here. Let me add the column in the given location. Before that, check this invisible so that you will be able to see the joints, and go to draw, click on the snap option, check these and all, check line ends and midpoints, line frames, intersections, and apply, and then click OK. So there is a column at here, there is a column at here, there is a column at here, and then column at here, 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 and then here, and then here, here. So the column whichever kept vertically, that will be rotated later also, like these all horizontal columns, and this column is kept vertically. So I select this column and then this column and then this column to be rotated 90°. I selected all these 3 columns and assign, go to frame, go to local axis, and then rotate it to 90° and click OK. Display undeformed section, undeformed shape. So you will be able to see the position of the column. This is exactly as per the preliminary design concept. So the column kept horizontally here, vertically here. So this is how it is looks like. This column I delete it here. So this is story 1. Sorry, this is drawn in the story 2, and the story 1 it is nothing here. These points are reflecting from the column base. So what you can do, so as per this floor plan, the first one is plinth beam and the second one is ground floor roof, which means the first floor roof is the second floor, the second floor roof is the terrace. Either we can say like in terms of roof or in terms of floor in the construction practice. So I modeled this ground floor roof, the remaining floor to be modeled with reference of these. So say like this is in the story 1, I copy this, I select everything and I go to edit, replicate story 1, the same frame replicated to the plinth level. What I can do, I can delete whatever not there in this as per this floor plan. So these beams and all not there. These beam also not there. These beams are not there. I delete all this. This is the plinth floor beams. So this is the plinth floor beams. This and all you can either merge by going this option. You can merge these two. Now it is merged to one member. It is merged here, and then you can delete these nodes and all by selecting it like this and delete it. Or else what you can do, you can delete all the dummy nodes by selecting object frame, select joints and delete it here. So all the dummy nodes other than the beam column joint nodes, all other nodes will be deleted. And in the base, change it to the fixed support condition. So as per the concept structural drawing, the plinth beam and the first floor has been modeled here. The above floors you can model as per the given beam location by removing beams and adding beams. So this video I made only to show you how to export from architectural to the Etabs. So you can take any critical beam floor plan and you can develop from that plan to the above or below floors framing plan, and then make a complete 3D model by adding the slab and adding the load and all everything, and you can do the analysis and design. Thank you guys for watching my video. For more such video, subscribe my channel. I will see you in the next video. See you. Bye bye.